Thank you for that kind introduction. Hello. Did you participate in the panel discussion earlier? Also, in yesterday's session in the panel discussion, you've learned about the latest attack vectors and very sophisticated modes of operation. However, traditional or classic methodologies are still being used, and we will have to cope with such classic cases as well. So today, I would like to share you a Malspam campaign that is, I guess, one of those kinds of operations. So let me introduce myself. I am Satoshi Kamekawa. I work at Itochu Cyber and Intelligence Inc., and I mainly handle incident response. So this is today's agenda. In 2025, we observed a spam campaign against Japanese corporations. So let me outline the spam campaign, detailing each of the attack phases. Then I will discuss countermeasures, followed by a summary. So, introduction. The campaign took place from September to October 2025. The phishing emails were used for initial access, with emails impersonating the Financial Services Agency and the Securities Trading Commission. And the body of these emails contain a URL, and clicking the link downloads malware. And a key characteristic of this campaign is that the attackers probably possess a substantial email address list, because they rapidly delivered a large volume of suspicious email within hours, and the malware families and implementations used during the campaign period change one after another. That's what we learned from our analysis. And now here's an overview of the campaign. And this is the campaign overview. There are multiple infection flows, but the basic pattern is like this. First, a phishing email is sent containing a link, and when you click that link, as you are led to a site at the top right, and file is downloaded from the URL, and executing that file then executes the payload, additional payload in memory. On the left is the actual phishing email text, and you can see it's written in very natural Japanese, and it impersonates a real existing agency. And during the campaign, a large amount of spam mail was identified with the same sort of titles, and the texts were the same, and the links changed from time to time. Now, at the top right is the malware download page, which I talked about earlier. Now, when you click the link in the mail body, it will redirect you to a landing page designed to download malware, and then the page performs a simple access check. And when you look at the source, it was verifying whether the user is in the Japan time zone, and based on this check, it decides whether to redirect you to a malware site. And if you're blocked, if access is blocked, then a fake reCAPTCHA screen like the one shown on the left will appear. Now, the mail was sent in large volumes during the campaign period, and this shows a heat map of the volume of mail sent, and the time zone was ETC +9. In our environment, the suspicious emails were sent in 5 separate waves in our time zone, and on each day, there was no regular pattern of at what time of the day the mail was sent. Now, for the details of the campaign, I said that suspicious emails were sent in 5 separate waves, and analysis revealed that the malware family and the configuration of the malware used were different each time. First, from the left, this is wave 1 to start with. Here, this sample could not be executed in a Japanese environment, and the malware configuration consisted of a loader first, and then the donut loader and valley rat. Now, in wave 2, we don't know if it was due to an attacker configuration error, but the malware could not be downloaded from the C2 server, even from Japan. As for wave 3, and this is similar to wave 1, the loader implementation was modified, however, to enable execution in the Japanese language environment, but the configuration remained unchanged. There was the loader, donut loader, and valley rat. As for wave 4, there were some changes. The final payload was changed from valley rat to a malware called V-shell, and the loader configuration was also altered, and it now fetches and executes a Python script from the C2 server to obtain the V-shell payload. And wave 5 had a malware configuration nearly identical to the 4th wave. So I will provide a detailed explanation of wave 1, and this was probably misconfigured and could not be executed in the download environment. Now the loader is a simple function that decodes shellcode using XOR. The loader checks for simplified Chinese or traditional Chinese environments. So it had that function to make the check. And I don't know, maybe it was a simple implementation error, or they reused code which has previously been intended for China or Taiwan for the Japanese environment. That could explain this mistake. But the email is in Japanese, its text is in Japanese, and its malware sites were checked to see if they were in the Japan time zone. So it likely targets Japanese organizations, but the implementations were clearly not for Japan. And the shellcode was generated using a tool called Donut. Donut Loader is a tool that converts scripts, exes, and other files into shellcode. It's normally used. And Decryptor is also publicly available. So if you use this, you'll be able to very easily extract the payload, and the payload uses valley rat. The valley rat, this is this slide, is a C2 framework, and with plugins, you can gain additional functions. So it's a modular design, but unfortunately, under our verification environment, the additional modules we could not obtain. One of the characteristics of valley rat is it includes config within the malware, which is very unique, and with this very special format, additional module download destinations, etc., could be defined, and the logging module can be additionally acquired due to the setup. Now, another feature is the payload that it can store in registry the additionally acquired modules, and it will check the registry to see whether the payload already exists, and the payload injects itself into the legitimate processes of the performance monitor. Now, valley rat encrypts communication data using XOR, using this routine for encryption and decryption. And the format is, now you have the packet size followed by the XOR key, and then the data itself are sent in that order.
And this is wave 2. This could not be downloaded. And then next is wave 3. And this is similar to configuration of Web 1. And the loader has been modified. And in the initial Wave 1 loader, it was for the Chinese language environment, but for Web 3 loader, the function for that has been deleted. And there's a single byte sample for Wave 1. But in this wave, it was the loader was using this kind of a helcode. And since then, there has been Valley Rat, and that was used as the payload. And the config was simple. So it was simply a change in the configuration of Wave 1, simplified. And then in the next wave, there was a major change. And there was a change from Valley Rat to VCL. And the loader configuration has also been changed. And initially, there was the Python script that was used by the attacker server, but then this has been changed to Snowlight shellcode has been described in it. And there's from the attacker server, then there is the payload of VCL. And in the first loader, there was C++ that was implemented, but then here you see that Python PyInstaller is used, and the code is as shown here. And there's the addition of the Python script, and this script is very simple, and there has been shellcode that has been hard-coded, and in coordination with the environment, whether it's Windows or Linux, the execution takes place for the shellcode depending on the environment. And then next is the third stage. And here you see in the vshell server, there is a shellcode from the loader. It's very simple. The VCL is the payload, and the download takes place, and the socket communication is used for VL. And as a feature, for the transmission packet, you look at the architecture's character string that is desirable as the IP address. And so the architecture uses VCL as the payload. And the VCL can be used for multi-platform. And you can see the signatures, and depending on the architecture, the appropriate payload is downloaded, and the payload is encoded and then decoded when it is executed. Next is the VCL, and this uses the Go language and the multi-platform. And the JSON format is used for the configuration, and this is encrypted as AES, and there is the sample 4.9.3 for the result. Next is Web 5, and this is like Web 4, but there has been a change in the configuration of the loader, and as indicated, there is some slight changes made in the Python script. As for the changes, the loader is temporarily stored within the terminal, and in the start menu path, there has been the addition of the start menu and the display, and there is the automatic execution of this. And since we were not able to identify any suspicious mail, but we were continued to monitor the CNC server, and there was the Python script that was replaced. This has been confirmed, and there is the Snowlight that is executed with the shellcode, and it is a simple whois query that is used in the script that has been changed. And through the campaign, the attacker created the malware and delivered it through the operations, and continued to execute this within short cycles. And so the attacks were confirmed over 5 different waves. And in regard to the contents, we can see the time that the contents was upgraded, and you can see in the web there is the timeline of the receipt from the web, and we can see the loader's compiler date on the upper side, and on the lower side you can see the C2 server. And just before the distribution of the mail, there may be the loader compilation that is made, and there are cases where there's the change in the CNC server. And for the wave 5, you can see that just immediately before it was distributed, you can see that in the C2 server, there had been distribution of the mail that has been made. Next is the analysis of the infrastructure. In the current campaign, there was the malware distribution server. There had been various types of disposable domains that had been used, and these are the tips for investigating the servers. And there had been a variety of different domains that had been used, but it had been the same configuration for the server that had been used. And so therefore, we looked at the characteristics of the contents and looked at the transmitted email. We looked at the domain and or the IP address of the originating server. And like this, we looked at the page title and some of the contents to determine the server and the domain. Next is the vShell server. And here, as mentioned before, if there had been the server program that had been made public in GitHub, and as an original the repository had been deleted, we looked at version 4.9.3, cracked version that had been leaked. And so in the current campaign, the version 4.9.3 had been used. And so therefore we believe that this had been used, and we looked at the various functions such as the execution of the plugin or the tunneling function. And we're looking at the VCL show fingerprints, and there's the Nginx fake page, and there's the basic authentication. And we looked at the basic authentication through the console, and we looked at the HM hash, and we were able to look at the VCL CNC server, and there's the default page title that is like this, and you can see the character string that is carried out like this. Next is the countermeasures. First of all, email monitoring. This is a very basic thing. And in regard to Japanese language email, it's going to be very important to look for the Japanese language email that is new, and it is possible to find the email that is involved in the campaign. Next is the network control measures. It'll be tough to do all of this, but for example, the direct IP address connection, that should be there should be limitations imposed on this, and also for specific protocols and controls such as WebSocket or DOT that is not used that frequently in an organization, then the best thing would be to block such items. And in regard to DLT or the default port 853 are examples of this, and also there may be cases when there's a new email, then it's necessary to do analysis to block certain CNC servers. The conclusions. The continuous research is going to be very important, and there may be cases of a large number of emails that are suspicious, then it would be necessary to look at the details of this. And it'll be necessary to look at what kind of campaign details can be found. And in regard to the campaigns attackers and where they are located, we believe that it's most likely Silverhawks, the group that is doing this, because of the Valley Rat that is used, and they have been targeting securities companies. And in regard to the campaigns, Valley Rat has been used for a variety of different campaigns. And in December of 2025, there had been phishing mail of this nature that had been observed, and the sample was Valley Rat configuration. And this seems to be a campaign that is targeting Japanese organizations. And so therefore, it's going to be important to continue to do research in this area. And with that, I would like to close off my presentation. Thank you very much.